Hello, good morning, good afternoon, good evening, depending on what time you're watching this video. This is Mr. Connolly. Today I'm going to be going through the hexadecimal number system with you. Okay, so our key objective is to understand how computers use the hexadecimal number system. And our outcomes for this mini segment is to be able to convert from hexadecimal into decimal and to be able to convert from decimal into hexadecimal. So, we already know about denary or decimal. That's the number system we use every day. Okay, decimal is to the base 10. Okay, uses 10 characters from 0 to 9. We now know binary. Okay, is the base 2 and uses 2 characters, 0 and 1. Okay, we know how to convert between binary and decimal. Okay, and we also know how to do addition and subtraction within binary. So, hexadecimal, it's the base 16. Okay, and if we look at the columns in binary, okay, we always go up by 2, so every time the columns double. If we look at denary or decimal, every time the columns go up by 10. Okay, so they're multiplied by 10. Hexadecimal, every time the columns multiplied by 16. Okay, so the first column's 1, the second column's 16, 256, 4096, so on and so forth. Now, the hexadecimal number system allows us to represent huge numbers by using a small amount of characters. So that's why it's useful when we're using them in computing. So, what is the number 1 worth in each base? Okay, so in binary, 1 is 3. Okay, so 1 would be 3 in binary. In decimal, 1 is 11. Okay. In hexadecimal, I know my slide's not worked exactly as I wanted it to. In hexadecimal, 1 is 17. Because here we've got 1 in our 16s column and we've got 1 in our 1 column. Okay? So, it isn't that simple though. We have 16 values now, so we can't use single numbers to represent everything. Okay? So we use letters instead. Okay, so now we can represent in 1 digit what binary would need to represent 4 digits for. So if we just have a look here, so we've got in hexadecimal 0 to 9 are represented using our normal numbers. Okay, the problem becomes in when we get to 10. So for the number 10 in hexadecimal we use the letter A. For the number 11 in hexadecimal we use the letter B, for 12 C, for 13 D, for 14 E, and for 15 we use the letter F. Okay, now when you do your calculations I would recommend writing this down or having this table to hand because it can be confusing when you first start using the hexadecimal number system. Now if we look at our binary numbers here, we can represent 4 binary characters with just 1 character in hexadecimal. Okay, which makes it very good when we're trying to cut down our space. So, how does it work? So 1 digit is easy, we just need to convert it. Okay, but what is 16 in hexadecimal? Okay, so if you think about it, if we go back to our columns in the last slide, this one, okay, 16 in hexadecimal is going to be 1 in the 16 column and 0 in the 1 column, so it's just going to be 1 0. Okay, and if we work it out, we've got it in our columns here, so we can times these numbers against each other. So 0 times 1 is 0, 1 times 16 is 16. Okay, so 16 in hexadecimal is 10. Right, so what we're going to have a go at doing now is doing 2 characters, a bit like what we did before, but we're going to do a slightly more complicated sum. So we've got the hexadecimal number 2f. So the first thing we need to do is split our characters in half. Okay. I've put in my hexadecimal headings here. Now you shouldn't need, actually I think there is one where you will need it when you do the calculations, where you'll have to go on to the next heading. So just remember the next heading is 256 if you need it, but in this example we don't. So we've got our headings 16 and 1. So what we need to do is we need to do 1 times 15, because remember f is 15 in hexadecimal, so 1 times 15 is 15. And then we need to do 2 times 16, so 2 times 16 is 32. Okay, so we know if we add these two values together, 15 and 32 is 47, so 2f is 47. Okay, if we convert it into decimal. Okay, so what I want you to do now, using the same method that you've just seen in here, okay, I want you to now have a go at doing these calculations. Now I do recommend when you do them that you write in the hexadecimal headings, and remember there is one, this one here, where you're going to have to go on to the next heading, which is 256. Okay, so if this hasn't made sense to you, okay, what I would do is I would just rewind it and watch this segment again. Okay, so if you want to now pause the video, and then I will go through the answers with you. Okay, so hopefully now you've completed the questions. We'll now go through the answers. Okay, so 1D should have been 29, 3E should have been 62, 4C should have been 76, 7A should have been 122, DA should have been 218, FF should have been 255, and 100, remember we needed to go into the next column for this. Okay, so you have your 1 column, you have your 16 column, then you have your 256 column. So if you've got 100, 1 times 256 is 256. So that's how that one works. Okay, so we're now going to have a go at converting back. Okay, converting the other way works as in binary. You only have to do 2-digit conversions. So start with the 16 column. Okay, you need to divide the number by 16, then convert it into hex. Then you take your remainder and convert it back to hex afterwards. Okay, so let's have a look at that in practice. Okay, so we've got 26. Sorry, we've not got 26, we've got the number, it's a decimal number 26. So what we're going to do now is we're going to divide 26 by 16. Now if you do that in a calculator, it'll give you 1.625. Okay, so we know the first number is 1. Okay, so you put a 1 in the 16 column. Now you've got the remainder 0.625, so what we need to do is we need to times it by 16. Okay, so you times the remainder, times it by 16, so 0.625 times 16, okay, and it equals 10. Okay, so if we work this out as a hexadecimal number, we now know the remainder is A. So the answer to converting 26, the decimal number, into hexadecimal number is 1A. Okay, let's have a go at one more. Okay, so let's do the decimal number 175. So we do 175 divided by 16, okay, which is 10, okay. So if we did it with a calculator, 175 divided by 16 equals 10.9375. So we know the first number is 10. So remember, in hexadecimal, 10 is A. So we're going to write A in the 16 column. Okay, and then the remainder is 0.9375. So we times it by 16 and we get the number 15. So we know 175 in hexadecimal is AF. Okay, now I will create an additional video where I do an example on paper. So if this hasn't made sense, okay, I will do an example with you where you can see me actually doing it using a calculator. Okay, so what I'd like you to do now is to have a go. I have included on here just so you can have a reference of how we did the last example. Okay, so if you want to pause the video now, there's 6 to do. And if you are struggling with this, I am going to do a little video to help you. Okay, so here are the answers. The first one, 57 in hexadecimal is 39. 15 in hexadecimal is 0F. 106 in hexadecimal is 6A. 240 in hexadecimal is F0. 160 in hexadecimal is A0. And 87 in hexadecimal is 57. Okay, now once you get this, it does become quite simple, but it's getting those first examples. So if you have struggled, I am going to do a little video where I talk you through this and I'll show you how to do it with a calculator. Okay, see you next time. Goodbye.